Welcome back to my channel. Today we're going to work on the question third maximum number. It's an easy level array question, and the question states, given an integer array nums, return the third distinct maximum number in this array. If the third match does not exist, return the match number instead. So let's look at the examples. Nums equals 3, 2, 1, and the third match would be number 1. Looking at this, there's only two numbers, so there's not even a third maximum. We just return the max instead, which is 2. And then the third example, you see there's like duplicates of 2. So 1, 2, 3 are the distinct numbers. The third maximum would still be 1. And looking at this question, we can solve it using a brute force way really easily, using sorted and set. So the condition we have to check for is the distinct, right? So to make a list distinct, we can use the function in Python called set. So let's see if length of set of nums. So basically what set does is if we have this list as our input, if we do set nums, then it will just give us 2, 3, 1. It gets rid of the duplicate. So if set nums is smaller than 3, that means we just need to return the max in this list because there's no third maximum possible. We just return max of nums. And then otherwise, we can return the sorted of the set of nums, -3. So it's like from the backwards counting the third one, that's the third maximum number for a sorted list. And let's try running this code, submitting it. Yeah, so this is how you would solve it in a brute force way. For solution using sorted and set. The time complexity would be O log n, O n log n, because sorted in Python uses timsort, and timsort complexity is n log n, and for space, no additional space is used, it's just O1. And this is a nice and short solution, but it might not be the solution if you're doing an interview, because the interviewer might not want you to use like things like sorted. So we can go for another solution here that gives you a better time complexity. I would use a heap solution. So let's import heap first. Basically for the heap solution, we maintain a heap. Let's first define our heap. I'll just call our min heap output. We define our heap kind of like our list. We just use output because this list. But what differs this from a normal list is later when we push our items onto our heap, we would use heap push and then pop it heap pop. So basically for this solution, let me explain it first. We'll go through our list of numbers, nums, and then for each one, we want to see, we want to push each number. Let's say there's 4 numbers here. We want to heap push each number onto our output. And then as soon as our heap gets to 3 numbers, we want to, more than 3 numbers, we want to heap pop it. So when we use heap pop, it always pops the minimum number. So always the minimum will be discarded from our list. So at the very end, if our heap has 3 numbers in it, we know the first number will be the third max. Sorry, I don't know if that explanation was clear, so let me just write this out. For num in set of nums, we'll get rid of the duplicates like we did earlier. So we want to start pushing heap push. We want to start pushing to our heap output with num. And then if at any instance, if the length of the output is greater than 3, then we want to do heap pop from our heap. And this will pop this will pop the min num of our heap. So at any given time, our heap will only have a maximum of 3 numbers. And if by the end of going through, iterating through our nums list, if the length of the output is 3, then we know that we can return the first number in our output. That would be the third maximum number, and then otherwise else we return the max of the output. Yeah, so this is how I would solve it using a heap. For the solution, the time complexity is O(n) because we only go through this list once, through here, and then the space would be O on constant of 3 because our heap at any given time only stores up to 3 values. When it's more than 3, we pop it, so O constant of 3 can be reduced to O constant of 1, so it's like O1 space with O(n) time, and this I would say is the optimal solution for this question. Let me know if you have any questions, and thank you so much for watching.